My name is Eric Swanson. I'm an application engineer at LAKOS Filtration. Been with the company about 7 years now. Help with a variety of product support through all of our markets. And we wanted to put together a product training on the screen filters that we introduced a couple of years ago. So this is more of a refresher training, product training, give you a little more confidence on product knowledge so you can sell it and support it better in the field. So topic overview, screens, what are they? Why are they important? Where do they go? Overview of the screens themselves. We'll go over some key advantages, how they work, the internal screen that goes inside of it, the housing, the different filter models, how we select those filter models is good to know, some best practice installations, some main key takeaway startup points on startup and troubleshooting when you're at a job site, and an example of some stage filtration you can offer for customers and when to apply them. So why would you offer a screen filter? Our separators are kind of our workhorse. They've been known to satisfy most of the application requirements for filtration. They're great at taking out the heavier particles, the solids, the sand, silt, pipe scale, rust. But sometimes a screen filter is a good supplemental or standalone filter, depending on what's in the water and what your downstream filtration requirements are. Some scenarios that would require screen filter over a separator would be these three below: variable flow outside the range of a single separator. So if your flow is just too variable, depending on the load, goes outside of the separator, screen filter might be a good addition or supplemental type of filtration for that. If there is no pump, it's all gravity fed, a separator is not going to be great. So you'd want some type of barrier filter, so the screen filter might be a better option. Or if the solids are too light, so if you're dealing with very, very fine material that's not going to be spun out through centrifugal force or organics, maybe a type of barrier filter like a screen filter would be a good option. General product overview. So they do have a small compact footprint for handling high flows, between 50 and over 7,300 gallons a minute for a single filter. That'll vary depending on what micron screen size you put in there. A smaller micron size kind of drops the maximum flow rate down so you don't overload the system. And you can bank them together for even higher flows. Micron rating range from 5 to 500 micron. It is important to note that these are meant for light to medium solids loading. If you have very, very dirty water, we would probably steer you towards something like a sand media filter instead. Otherwise, these may get overwhelmed prematurely and backwash too much. They do have continuous automatic operation, so you don't have to have anyone on site monitoring or operating it on a continuous basis. It'll backwash itself on its own based off of differential pressure or a timer. You don't have to have someone there on site watching it all the time. It is all stainless steel construction. The housing is 304 stainless. The internal screen is 316 stainless. And if you have any applications where it needs to be drinking water safe, NSF 61 certifications do come with this. We can provide that documentation if you have customers that need it. Some quick key advantages of these. They are all stainless steel, like I mentioned before. Some other designs out there on the market do include some PVC back screens, a little less robust that way. So you can be confident that this is all stainless steel construction. So it's pretty beefy. It does have a compact design. So relative to other types of systems, you may have multiple sand media banked together or just one large sand media tank or other types of filters. This is a relatively more compact design. So if you have some room constraints, this is worth looking into. It does have relatively low water consumption for cleaning. Typically about 1% or a little less than 1% of the incoming water flow is used for the back flushing. So factor that into your design, but it's still pretty low. And like I mentioned before, it does offer a continuous automation and self-cleaning backwash. Some quick overview on the main components of these screens. I'm going to be throwing out some nomenclature, so in case you guys aren't sure, this is a good slide to reference. When we say dual screen on all of our screen filters, dual screen means it comes with a coarse screen right here at the inlet and also a fine screen as a secondary stage filter, all within the same housing. That's all that means, dual screen filter. So this will be a 1/4 inch perforated screen, and then this is what you would select based off of the downstream filtration requirements between 5 to 500 micron. All screen filters will come with a flush valve right here at the top. This is the little piston filter. So this is the hydraulic tubing that connects the flush line port to the end of the piston. that just equalizes pressure here. So whenever it goes in the back flush valve, it allows the piston to move and flush it out. And whenever it's done flushing, this equalizes again and pushes the piston back over. This is the piston itself. A very important thing to note is this rod position indicator right here. Always be aware of where that is. This is the only real way to know what's happening on the inside. So if this is moved all the way over to the right, that means this rod on the inside has also moved all the way over to the right. So you don't actually have to open it up to look where it's at. The hydraulic models will have this rotating sprinkler. The electric low pressure models will not. Instead, it'll have a motor mounted over here on the side to help rotate this internal particle remover rod, which is what this is right here. These are all the suction nozzles. There will be multiple depending on the size of the screen. This one shows 5, but there can be more. Dirty water inlets, clean water outlet. So this is just a general overview of all the main components. Each screen filter will have its own controller. It's not shown here, but just note that there's also a controller involved. Typical filtration mode. So this example just uses 50 PSI at the inlet just for example purposes. So you got water coming in, hitting the core screen filter. So it's coming from the outside inward into the inside of the core screen filter. Then it flows horizontally from the inside of the fine screen filter to the outside, out the outlet, clean water. So all the dirt and debris is going to be getting stuck on the inside of this internal fine screen filter and on the outside of this coarse screen filter. The only way to clean the coarse screen filter is to remove this end cap, slide that out, clean it, and put it back in. But you really shouldn't have to be doing that very often. You got some upstream filtration or supply issues that you may want to look into if that's the case. This is really meant to just protect these spray nozzles on the inside from being exposed to too large of particles, otherwise they can get plugged. That's really what this is for. So as the screen builds up debris on the inside, the differential pressure between the inlet and the outlet should increase. So your pressure at the inlet will become higher. You'll be losing pressure at the outlet. That's how we know that differential pressure, the screen is building up debris on the inside. The flush line valve has not opened yet, so this should still be relatively equalized at or roughly about the same pressure as the inlet pressure gauge. As soon as a differential pressure of 7 PSI between the inlet and the outlet is reached, that is when the backwash, the suction flush mode is initiated. The controller will tell this flush valve to open up, exposing it to atmospheric pressure. So it should drop to 0 or near 0 PSI. And it's the difference between atmospheric pressure and the inlet pressure to the screen filter is what really drives the suction cleaning action. So the higher the inlet pressure is relative to atmospheric pressure, the better the suction cleaning will be. The filtering's still happening. You're not cutting off downstream water supply, so you're still going to have water going downstream. Some of the water will be actually going out the flush line. You're basically moving a little bit further out right on your pump curve. So you're flowing a little bit more water because you have some more water going to the flush line and some water going out the clean water outlet. So when you're actually selecting your filter, it is actually important to select it for the pressure rating based off of what the total flow would be when you're in backwash mode. It might be just a couple PSI difference, but it's worth noting. This rod position indicator has moved from the home position to the right, so it's moving this direction. You'll actually be able to see it slowly moving towards this way. If you have a higher pressure at the inlet, it'll move faster. If you have a lower pressure at the inlet, it'll move slower. So it's important to watch this and count how long it takes to move all the way across, because that's what you're going to use to set your flush duration timer on the controller. It's an on-site part of the startup procedure. So just keep that in mind. The way it backwashes itself, so since you have a vacuum from 50 PSI to atmosphere, everything is going to be sucking through these suction nozzles. It rotates because of this sprinkler suction spinner right here at the end. It's almost like a turbine, but it's not actually a turbine, but it does rotate due to the suction effect. And it moves horizontally just because the water is coming in and moving to to the right, just pushing this piston rod to the right. So that's kind of how it rotates and moves at the same time. After the suction process is completed, this pressure at the flush and the inlet pressure will have equalized again. So the piston will be able to return back to home base. You'll be able to watch that indicator right there move all the way back to home. You want it to make sure it does go all the way back. That's how you know it's gone back to home base. And you should have a clean screen again, basically. 50 PSI at the inlet, 49-ish PSI at the outlet. 0 to 1 PSI is pretty average, pretty typical for a clean water screen differential pressure. And this is just a quick summary on what we just talked about. One continuous cycle of clean conditions, debris builds up on the inside of the screen, it's dirty, cleans itself, back to running in normal full flow clean conditions, and just repeats itself automatically. The standard screen on the inside is going to be our centered screen. It's 316 stainless steel. It's a mesh fused to stainless steel perforated plate for durability. It's basically the same. That perforated plate is basically the same as the coarse pre-strainer on all of our dual screen models. It does have micron options from 5 to 500. This is going to be more common. It's the most common one. I'd say 95% of your applications will be the standard centered, so you shouldn't have to specify anything different. The only real time you'd want to use a wedge wire is if you're dealing with stringy fibrous material, which causes a little more issues on other standard screens. It kind of gets interwoven and it becomes a little more difficult to remove off of it. So a wedge wire design is a more beneficial design for that type of application. It's a little more expensive, so just keep that in mind. Not much, but it is more, and it's not offered in the very, very fine micron options. 25 micron would be the smallest. So just be aware. Here is an overview matrix of all of our screen filter models. We got dual screen heavy duty, dual screen standard duty, and dual screen or single screen standard duty. The dual screen, like I mentioned before, just means it comes with a pre-strainer at the inlet and a fine screen. The heavy duty is in reference to a body flange connection, and the standard duty is in reference to a clamp style connection. It's a little bit lower cost method that way. It is important to know that the body flange, the heavy duty version, is built to ASME standards. It doesn't come standard with the U-stamp. That is an available upgrade, but it is built to ASME standards. So if you have a customer asking, that is available. The single screen standard duty does not have a coarse strainer up front, but all the other automation is the same. The water is going to be coming in through the side and hit this into the inside of the fine screen and come straight out. So there isn't a coarse screen. If there was a coarse screen, it would be here, but it's not. Note that the dual screen heavy duty does allow for higher flow rates, and it does have up to a much higher screen surface area. We have multiple models for each one of these, the dual screen, standard duty, heavy duty, and single screen. This is just a summary of what the maximum of each can do. They're all rated to 150 PSI maximum pressure, 200 Fahrenheit degrees, and all have a 304 stainless housing with 316 stainless internal screen. Selecting the models, we need 4 bits of information: the flow rate, the micron filtration required, the solids loading, and the inlet pressure. So 1, 2, and 3, the flow rate, micron, and TSS is all used to determine the minimum screen surface area required. The inlet pressure is just used to pick the flush method. So if these next few slides seem like a bit much, don't worry, you can always contact me or anybody at LAKOS to help select a model, but I just wanted to give you guys an idea of how we go about model selection and picking the minimum screen surface area required. This table is available on our website and on the brochure. I just wanted to go through a quick example. It is worth noting that higher flow rates generally mean you need more screen surface area. A finer micron screen, like if you comparing 100 micron to 25 micron, the 25 micron, if the flow rate is the same, you're going to need more screen surface area. Otherwise, you're going to get premature differential pressure and you're going to get some flow restrictions in the line. So you want to make sure you size it properly. So for an example, say you're running 1,000 gallons a minute, you got 100 micron downstream filtration requirement for your your nozzles to work properly, and you got a average solids loading of say 26 to 70 ppm. It might be less, might be more. This is just an example. Based off the table, at 100 micron, moderate water quality, this is going to be our multiplier, 1.389. So you just take your flow rate divided by 1.389, that gives you your square inches, 720 square inches, which is 5 square feet. So you want to use 5 square feet as your minimum screen surface area for selecting your screen filter. Going back to our options, the dual screen standard duty has 5 square feet, and the single screen standard duty goes up to 8 square feet. We have smaller square footed versions for each of these, but this is just an oversimplified example. So you could go with the 6-inch dual screen standard duty hydraulic with 5 square feet of 100 micron screen area, or if you're confident that you have relatively cleaner water and you're not going to be experiencing larger particles coming in to block the suction nozzles, you can go with the single screen, less expensive 6-inch single screen standard duty hydraulic. Same screen surface area, same micron rating, it just doesn't have the core screen. So you have options. So this next slide, all this is really showing is that if instead you wanted 50 micron instead of the 100 micron, you're going to need a larger screen surface area. All things else unchanged, still 1,000 gallons a minute, still same inlet pressure. You're now going to need 10.1 square foot. So if you were to cross-reference this with our brochure or our website, the next standard size up would be 12.25 square feet of our dual screen. And since this is a minimum of 10.1 square foot, you can no longer offer the single screen standard duty because it caps out at 8. You're really stuck with the dual screen heavy duty because it goes all the way up to 24.5 square feet. So that's how we go about sizing these screen filter area. Typical installation, this is just a very basic best practice installation. You're going to want isolation valves, one at the inlet of the screen filter, one at the outlet of the screen filter, and you're going to want a bypass valve. So this is just good standard practice in case for whatever reason you need to service this or just take it offline, you have that option. The flush valve, it is very important to know that whatever flush valve size that you get with the screen filter, say for example, this is an 1.5-inch flush valve, you're going to want to bump that up to at least a 2-inch flush line to minimize any kind of back pressure. Because remember, you want that flush to be at or near atmospheric pressure. You don't want back pressure that inhibits effective cleaning of the filter. I mentioned the low pressure electric version with the motor. So this is what an installation would look like for that. Over here on the left side is the electric motor. It's a 90 volt DC electric motor powered by this control panel. Everything else is the same. It's just how the screen filter cleans itself it gets a little extra boost because it's such low pressure that it can't clean itself on pressure suction alone. When you're on site, it's very important to keep these things in mind. Top 3 things that I get calls on, or I'm talking with customers or at a job site or at an installation, these are the most common ones that come up, so I wanted to share them with you. Make sure that the inlet pressure meets the minimum requirement for the flush method used. So if you're using a hydraulic type screen, you want to make sure that the inlet pressure is at least 40 psi. If it's less, we'd have to run the numbers and look at it, but if you really want to stay simple and make sure it's working properly, you want to make sure that it's at 40 psi. If it's less than 40 psi, we would really encourage and require it to be the electric low pressure version, which has that DC motor on the side. So if you have a customer with the hydraulic version, but their inlet pressure is only 20 psi, that should be a red flag that it was not selected properly at the get-go. Hopefully that's not the case, but it is worth knowing that so you can help them solve their problem. The flush duration timer on the controller, we talked about that indicator on the piston, that black indicator that slides back and forth. That's what shows you the position of the internal particle remover rod. So the time that it takes to slide all the way across, that should be what your flush duration on the controller is set to at a minimum. So if it takes 15 seconds for it to slide across, set the purge to 20 seconds. You don't give yourself a little buffer room there. If you have it set for a minute, all that's doing is the rod's not moving anymore. It's already pinged out all the way to the right. So it's going to be sitting there for 40 seconds, suctioning same spot over and over and over. So all you're doing at that point is just wasting water. You're not actually doing more of a cleaning. So it's a fine tuning between making sure you clean the screen and don't waste water. And the third most common thing is make sure that the flush line pressure gauge reach 0 psi or near 0, because you want to be flushing to atmosphere. If you have valves and long pipe runs and elbows and you're reading 10, 15 psi on that flush line, you're going to have a difficult time actually cleaning the screen because the differential pressure between the inlet and the flush line just isn't great enough. And some cases do require a variety of filters in series. So applications with a variety of solids, ranging from heavier particles to lighter particles, we generally would recommend a stage type of filtration. So it allows the separator to take out the heavier particles up front, allowing the screen filter to really focus on what it's good at, so it does not get overloaded and backwashing too often. So this is a common solution for applications. You may be pulling from a river that may have sand and organics, or whatever application you run into that has a combination of solids that you're dealing with. Stage filtration is a very good solution to solve those problems. If you have any questions, you're always welcome to reach out to us at the factory. Again, my name is Eric Swanson, application engineer for LAKOS. You're always welcome to reach out to any one of our regional sales managers or anybody inside sales here at the office. Be happy to take your calls and help you out with any of your filtration needs. All right. Thank you.